Hello everybody, welcome to my video. I'm Ali and here we are making some tutorials for Qiskit developer exam. This is going to be the second video, and unlike the two other videos that I have like a very dark background, here I introduce you to my sort of like office part of the house. And here is where I code, work on my PhD work, and sometimes I open LinkedIn and cry. But anyway, let's go and dig in. Today we're going to talk about the first step before doing any circuit design or anything. The first step is to setting up your environment, and we're going to dig in on how to set up the environment. Here, what do I have here? Here I have a Jupyter notebook opened. Is this a cheat sheet? Yes, it is a cheat sheet for you. It's going to be uploaded on my GitHub, and then you also have an access to that. So after the video is done, you can go and open it up, download it, and you can go the steps step by step by yourself. The first step is to actually install Python or any distribution that not only contains the Python language, which is the language of the Qiskit, but also has some other useful packages. There are different distributions. One of the most common ones, and the one that I use and I recommend, is Anaconda. So the first step is to install the Anaconda on your computer. Based on the operating system that you're using, there are different ways to do that. Here on the first cell of the Jupyter notebook, I have the link to the website for Anaconda to download that and have an instruction for different OS. So I'm going to skip that part myself because I have Anaconda on my system already installed. And but if you have any issues based on your operating system, you can let me know and I can make a video about that. Okay, so the next step after installing Anaconda is to choose an IDE. It is short for Integrated Development Environment. Basically, the environment that you are going to do your coding here. What you're seeing here is the Jupyter notebook. This is my IDE, or this is IDE that I choose. There are other common IDEs like Visual Studio Code. They all have their own benefits. Like, for example, Visual Studio Code, you can easily like install other languages and do the coding on different languages. And it seems to be a little bit more customizable, but I would say this should not be the step that you spend a lot of time at the beginning on it. After you become more comfortable with the coding part of the quantum computing, you can actually search and find out the ways that you can customize your IDE the way that you like it. I may even make a video about that too. And you can kind of like make the environment the way that you feel more comfortable. It has less strain on your eyes. You may heard that like many of the coders, they jump and go straight to the dark mode because it is less taxing for your eyes to spend a lot of time, a lot of long hours in front of your computer. At the end of the day, the choice is yours. I'm going to continue with the Jupyter notebook, especially that if you install Anaconda, you already have a Jupyter notebook on it. So it makes less friction for the newcomers. After that, now you have your Python installed through Anaconda. You have your Jupyter notebook also installed. You have your environment ready. There is one other step that if you are a newcomer, you can actually skip it for now. But it is a good habit to have in mind. When it comes to having different projects, there are a lot of times that you need to work with packages that, for example, are not working with the same version of the Python. So for one project, you may need like Python 3.8. For another one, you need the latest version. And the conflict with these two projects that you have can be frustrating and can cause errors that in future is really hard to trace it back or solve it. So what people usually do is that they make sub-environments. Basically, they make a new environment for each project. So in that environment, they only have packages with the versions that are compatible with each other. I'm going to give you an example of that. I'm using a software called Mantit. It is being used for Neutron data, and it only uses Python 3.8. So I needed to make an environment with 3.8 version of the Python to be able to basically import all of the modules to the Jupyter Notebook and continue my work there. If you feel that you want to skip this step, I don't blame you. And you can go to the timestamps that is being written here. You can come here later if you want. But now, I'm just gonna, with you, try to do a content environment and basically continue the project in the new environment, or like continue the installation in the new environment and see what kind of problems we can have. If you look at the Jupyter Notebook, you can see that the managing environment is kind of highlighted with the green color. Depends on the team that you have installed your Jupyter Notebook. It might be a different color, but the point is that it is actually a hyperlink. When you click on it, you can actually go to Conda environment page, like managing environment page, and get more information there. But for now, we are just going to make a new environment and continue our installation process in the new environment. Okay? Depending on your operating system, you either going to use Anaconda prompt if you are using Windows as your operating system, or Terminal if you are using Linux or Mac OS. So the first step is to open Anaconda prompt or Terminal. To do that on Mac OS or Linux, you can do Control Alt T. And after that, we are going to follow the instruction. So the syntax to create a new environment using Conda is Conda create _name. And here my env is the name of the environment that I'm going to make. You can here also choose the version of the Python, for example, that you want. So Qiskit package uses the latest version of the Python, so I'm just gonna let it go with without specifying the version. So I'm gonna go with Conda create name, and I'm gonna call the environment Qiskit tutorial 1. Okay, now what you're seeing here is that it starts to make that environment and asking you for some permission. And what the answer to that question basically confirms that this would be the location of the environment, and it starts to making that. What you can see here is that your environment by default is the base environment. And if you want to go to the environment that you created before, every time that you open the terminal or Anaconda prompt, or you want to start your work for that day, you need to actually switch to that environment. So what I'm going to do is write down Conda activate Qiskit tutorial 1. See, now you can see that I'm right now in the Qiskit tutorial 1 environment. I'm gonna go to base again. I also gonna close the terminal that I had open here. Close terminal, yes. Then I'm gonna have the terminal open. So I'm gonna use the terminal in the environment that we just made here. Perfect. So we're going to go to Qiskit tutorials. Now we have Jupyter Notebook open. Perfect. The next step after doing this is to install Qiskit. You have basically your environment ready. You need to install Qiskit, and after that, you're ready for your first circuit. That is going to be a subject of the next video, actually. So to install the Qiskit, you can use the pip. Pip is the common way to install packages in Jupyter Notebook. You can use that in the terminal if you're in the right environment, or you can do it directly in the Jupyter Notebook. If you want to use the same visualization that you can see in the Qiskit textbook, it is better to install like a Qiskit visualization. You can find the syntax for that here. So I'm going to say like a pip install Qiskit. Okay. Maybe that's the problem. That can be an issue. That can be an issue that you don't have pip actually installed. To open, to install pip, I'm going to go here, open another terminal. I'm going to go conda activate my Qiskit tutorial 1. Of course, it's not because I have a typo. Then I'm going to go sudo apt install Python 3 pip. As for my password, yes. Yeah, that is something that you probably confront to do that too. Like that's the tricky part about like new environments. Some of the packages are not installed. You probably need to install it yourself. So I should have the pip right now installed. I'm going to close this terminal. I'm going to restart my kernel. Then I'm going to pray that pip is installed. Yes, pip is installed. So the next step that it's going to do is to actually get the Qiskit visualization package and installing that. As you can see, it is continuing to install. Some warnings, but it's not a problem. It's going to take a minute. And then whenever you install a new package, especially inside a Jupyter Notebook itself, you probably need to restart your kernel. I'm going to restart my kernel. Good. Now that my kernel is restart, I'm probably not going to run this one again here because I already have Qiskit installed on my computer. The next step is that since we just follow a lot of things from the Qiskit textbook, which is a very good reference, I will also prefer to install the Qiskit textbook. So it would be easier for us to get the visualization the way that is in the Qiskit textbook. Hey, now the pip works again. So we are happy that pip is working without an issue. So you can run this cell and it's going to install the install the Qiskit textbook on your new environment. This is going to take a minute to successfully install. That is good. So there are other steps that you can take to like make the pre-rendered version of your circuits more similar to what you can see in the textbook. There are options that you can change the drawer default to text, MPL, LaTeX, or auto. These are the things that we actually going to play with and show that in the next video that we are going to make our first circuit. But I'm just going to have the syntax here shown in the just Jupyter Notebook cheat sheet for you. And you can play with that yourself too. After you install your Qiskit and Qiskit textbook, one of the important things to know is to know the version of each of your Qiskit sub modules. You can get those information by just like importing Qiskit tools, Jupyter, and then print the Qiskit version table. So here you can see I have okay. So you noticed, you saw that I got an error. Qiskit version table is not defined. To actually put percentage sign before that. And then now you have your Qiskit versions for different sub Qiskit modules here. You can also see your Python version, Python compiler, and more information. You can also see your OS and number of the cores and CPUs. Okay, that's a little bit too much information. This is not the only way that you can find out what is the version of your Qiskit. You can use the other two syntaxes to find out what is your Qiskit version. One of them is just Qiskit dot underline underline version underline underline. The other one is that Qiskit dot Qiskit Qiskit dot underline underline Qiskit underline version underline underline. So what is the difference between two? Let's show it here and we can find it out. So if I comment this one, it's going to only print this one. Yeah, you're just going to get 0.22.3, and if you compare it here, that is actually only showing the Qiskit Terra version. But if I put this one, if I make it as not a comment and print it, you can see that you get basically most of the information that you got when you are using the Qiskit underline version underline table. It has almost all the information there. Okay. If you're using a Jupyter notebook, there are Jupyter specific tools that you can use. Some of them are shown here in this slide. For example, we saw that you can use the Qiskit version table to find out what is the version information, Qiskit version information. The other ones that we are going to talk about it later. You can find out what the backends are available. If you are submitting a job, you can actually see the job and follow the progress there. Now that we have basically all of our setup being set, now let's go and review a little bit of Python. If you are new in Python, we can start with the arithmetic. That is very simple. Addition, subtraction, multiplication, and division. Here I also imported NumPy as a package that helps us to use other functions like the absolute value or when you want to use pi. You can also have those numbers as variables and then do your arithmetics with the variables. One thing that comes to mind here is always remember the order of operation. That's gonna prevent you from unintentionally making mistakes. So parentheses always have higher priority to exponents. Exponents have higher priority to multiplication or division, and multiplication and division has higher priority to addition and subtraction. One other thing is to remember that in Python, how many or what kind of variables we have. In Python, we have about like 5 kind of variables. One of them is integer. You only have like an integer. Float, Boolean is a variable that can only be true or false, or 0 or 1. Strings are just like text. None itself can be a variable. So here I'm trying to define different variables. We also check to see that if they have the type that we expected. So here a is 42. I'm going to print that and see that a is an class integer. To do that, to find out what is the kind of variable that you have, you can use the type function. And the reason that I use the str here is that when you're printing, all of your formats should be the same kind. So I'm using the string here to say a is an. So to have the to be able to combine that with the type of a, I need to make the type of a to be a string too, so they can combine these two and print that. Let's go with the float. B is 36.6. It's obvious that it is like a float, and we can see here that B is a float. C is a little bit more interesting. Remember that when you are putting a dot after 42, you actually define the position, and in that case, it's not going to be an integer anymore. In this case, it is a float variable. Booleans, true or false, and so I have f equals to true, g equals to false. So for booleans, we can see like f is true, g is false, and when you print the kind, they are booleans. Strings, as I mentioned before, they are text. They can look like integers or floats, but when you have the quotation or like a double quotation, they become a string, and they're not like a float or integer anymore. You can change them. You can actually make m is float I and n is int I, and then I'm going to print these here to find out what is the kind of the m and n. And you can see that m and n, m is float, n is integer. If you try to float or integer something that is not able to convert, it's just going to give you an error. J is a none, and when you print the type, you're going to get none. The other thing that is important to have an idea about is the difference between list, tuple, and array. That's going to help you to prevent a lot of future problems when you try to do your coding and you try to defining the variables in an array or a list. So we are gonna start with the list. List is an ordered collection of data types. It is mutable. Lists are dynamic and contain objects of different data types, which is important. You cannot do arithmetic operations on a list. We are gonna try to see if that works or not and what we are gonna find. List elements can be accessed by index number. That would be very helpful. So imagine that I have a list of the steps that I should take in future in the next year and a half. I need to have more publications. I need to write my dissertation, get ready for defense, find a job, and pay my debt. Terrifying. So I want to find the items from number index 2 to index 4. We can talk about indexing here. Indexing, always start from 0. So 2 to 4 should be defense and job, because it doesn't really contain the last element. So 0, 1, 2, 3, 4. So 2 and 3 are going to be the ones that we are choosing here. So when you're printing that, you only expect to see defense and job. That is right. The next step is that you can change the item in the list by using index number. I'm going to change the publication. Sorry, I'm going to change the dissertation to healthcare. Probably I need to check on my insurance right now. And you can choose the name, choose the element in the list, and you can change it with the other things that you want. You can make arithmetics on the items in the list separately. So for example, you can have the second is going to be index number 1, or the second term. I'm going to make it to be twice as the third term. And to do that, you can basically choose the first one to be the second. So to choose the second item to be the third item times 2. And when you do that, you're going to find that it's 19.6, which is twice as 9.8. And the other thing to remember is that the last item, you can start indexing from the beginning, which is start from 0 to the length of the list, or you can do inverse. When you say -1, it starts from the end of the list. Now, list of floats that I have, times 2. What does it give me? It's going to give me, it doesn't really multiply each element by 2. What it's going to do is that basically print the list 2 times. So now we have, if you have list 3 equals to list float times 3, and then you print your list 3, you're going to see that it's just like copied 3 times. What if I do 3.1 here? Here's where it's going to give you an error, because it cannot copy non-integer times. I cannot copy any list non-integer times. That's if you're lucky and you by mistake trying to multiply the list by non-integer value, you are going to get an error and you find out that you're making a mistake. But if it's an integer value, you may by mistake just make your list larger instead of like multiplying each index that you want. Just keep that in mind. The next thing is that we're going to talk about is the concept of array. Array, similar to the list, it is mutable. It is ordered collection of the similar data types. Here, the important factor is similar data types. You can use you can access the elements using the index value for that. You can do arithmetic operations on the array. So now I'm having I define an array using a NumPy array function. Then I can actually print that using basically here it is you don't need this print here. Okay, here is basically goes from range of 0 to 3 and prints the value for the value in the A array from 0 to 3. You can do that easier just doing that. The same thing, the same way that you did that for the list. The other thing is that I mentioned that there are going to be the similar data types in the array. So here I have integer, integer, float, float. So let's print that. So I want to find out what is the type of the first item on the array B. First item on the array B is actually float as the last item. So what is that? So the way that Python tried to interpret that is try to find a variable kind that can encapsulate both of them. You can always have an integer being defined as a float. It kind of gives that a false precision, but that is how the Python tried to fix that issue. It tries to make everything to be the same kind. I have the example here too. Here we have integer, we have a string, we have boolean, and we have float. Let's see what happens when you find out what is the type. You can see that string is the kind that can encapsulate all of them. So basically Python, to keep that to be an array, convert all other ones to a string. The last thing is a tuple. Tuples, similar to lists, but the fact is that they are not mutable. You cannot make them longer or shorter. They are basically fixed and defined. It's usually for a case that you want to get sure you're not going to change anything in there and it's going to be fixed. And the way to define it is a little bit different. You do the parentheses here, and you can access the items in the tuple, and you can basically, based on the index, you can use the range, or you can just access one item. The last thing is functions. You should remember that at the end of the day, most of the times we end up making our own functions based on the needs that we have. So it's important to know how to define a function. To define a function, you need to use a def, the name of your function, and the inputs that you want here. Here I'm trying to import a plot and show it. So for that, I need matplotlib package. and I need matplotlib image package. So I'm going to import them. This is my function, and this function gets the directory of the picture, import it, and plot it. So here I'm going to use the image plotter. See, what do we have here? It takes a long time. Here we go. Yeah, okay. That's a good reminder. So if you enjoy the video and want to learn more, and you want to join me in this journey, please like and subscribe and ring the bell to get sure that you're going to get more videos. I also want to thank you, the other people who watched my previous video, and the one who actually messaged me to ask me when would be the next video. I really appreciate that you're holding me accountable, and I hope that my video is going to be useful and you can start your journey here in the field of the quantum computing. I'm going to see you in the next video.